Hey, it's Eric G. Around the House is sponsored by Baldwin Hardware. For 75 years, Baldwin Hardware has been known for its first-class quality and craftsmanship in door and cabinetry hardware. As an alumnus of the Baldwin Hardware Design Council, I can say I have seen the details and quality from design to the finished product. If you're looking for a new style and old-world craftsmanship, I can tell you there is only one Baldwin Hardware. Check out what would look great in your home at baldwinhardware.com.
It's Around the House.
Trash is like a whole nother environmental thing that we don't talk about, right? Mm-hmm. It's like you put it out for the curb and it's like it's gone.
It's forgotten, right? It's like, out of sight, out of mind.
We don't talk about the 102 tons of trash we make in our lifetimes or whatever. Like the example they use in the book is like you look at the hoarder house and that's like the stuff that they just didn't send to the landfill and that's all of us. They just kept it in one place. And so you think about that and then that's kind of almost like an impact of like, oh my gosh, if I make that much trash, right? And it's really apparent when it's all in one place. But when you're just like, put it out to the curb, like gone somewhere else, it's, set it and forget it.
When it comes to remodeling and renovating your home, there is a lot to know. But we've got you covered. This is Around the House.
Welcome to Around the House Show. This is where we talk everything about your home every single week. Thanks for joining us. We have a great guest back in the studio today, Emily Mottram, Mottram Architecture. Welcome back to Around the House.
Hey, thanks for having me. It's always a good, fun afternoon to hang out with you.
This is always fun. You and I can get into the weeds on this stuff, which is super fun to me. You've got so much going on as well, from a book to architecture to speaking. You're like everywhere. I don't want to see your schedule because it's got to be like this crazy flow chart because you're everywhere at the same time.
It is a little bit crazy. Some days you wake up and you think, what did I do?
I get the same thing where I'm getting up in the morning and one eye open, looking at my Outlook calendar going, oh yeah, that's right. I got that today.
Yeah, no, same here. It's like, how soon do I have to be presentable for a meeting I'm going to be on camera for? And you'd love the day that you don't have any of those, but I don't think they exist anymore. So it's
You're
like
a mythical unicorn.
I gotta be presentable by this time. So I gotta be done doing email or whatever else I'm responding to or doing, and make sure that I'm at least, you say camera ready, but I mean, it's kind of, Zoom is a stretch, but
yeah. What's interesting though is, and I ran into this with design, and I'm sure you run into the same thing with the architecture. When I get focused in a project, time travels fast. Like when I'm like totally zoomed into, okay, I have to get us from point A to point B. And then you look up and go, I thought it was 2 and it's 4.
Yeah. And I think the thing that we sort of forget is we got all these other things going on and it's like, there looks like there's a block in your schedule, but you need that time to spend 2 to 4 hours, like deep dive into your project stuff too. And so for me, it's a balance between making sure I have that time and I didn't miss a meeting I was supposed to be at, but also making sure I don't put so many things in my schedule that if I only have an hour in between something, that's oftentimes not enough time for a really creative process to happen. Mm-hmm. Like I might be able to get one little thing done or redline a detail for, our production team or something like that. But there's no way I'm doing hard, super creative things in a short window of time. And that's been my battle this fall, is making sure that I leave enough creative time in my schedule. Cause it looks like there's this 3-4 hour block of time. Like, this is great. And all of a sudden you blink and that time is gone.
Caught up on the emails, but the design time didn't happen, right? So it's interesting, because there's so much going on right now. It's so hard to even stay on top of stuff. I don't know if you even had a chance to catch, and, we don't talk politics in here, but that new energy standards that are coming out here in like January for heating and cooling stuff because of that whole Inflation Reduction Act thing. Have you been seeing and following on some of that stuff? I'm trying to stay on top of it, but it's tough.
I can't stay on top of it. There's just so much going on. And so it's like, oh, you see it, you flip by, you save it. You're like, I'm going to read that. I'm going to get into it. I'm going to take an amount of time to understand what that meant and how that impacts everything. And then it's just like, boom, it's gone. And you got distracted by something. And it's like, you see it pop up again and you're like, oh no, wait, I got to read that. So
exactly. Well, one of the things that I noticed, and this is just kind of doing the 30,000 foot level, because we're not going to get into the weeds on this, but it looks like if you're a homeowner out there and you're wanting to get some of these rebates and you say, okay, I'm going to replace my air conditioning in my home, that you're going to have to put in a more efficient and matched system. So you're going to have to change the whole unit out versus just change out the heating or the cooling part of it. So we're going to see that. And I saw that they're measuring HVAC differently than just your SEER ratings now too. So I think it's going to be a little complex early part of the year as everybody figures out what's going on out there.
And I feel like it's going to be a little complex and it's going to be a little frustrating, both for the professionals and for the homeowners as we navigate that. But I also feel like the one thing in the arena that we don't talk enough about is mechanicals, right? Like we need to do some of this stuff. We need to be tracking. We need to know what's out there and what isn't working so that we know how to move forward. For a couple of years, it was this struggle with, low load homes and traditional HVAC systems, right? And then, in cooling climates, not running long enough to have any kind of dehumidification, needing more dehumidification in heating climates, short cycling and having all, wasting all this energy. And then, now we talked briefly, like we wrote a book, right, talking about it. And in some of it, it's like we default to mini splits, right? That's kind of like a default thing.
Sure.
But is that the right answer? Maybe not, but it's what we have right now. It's like, oh, why are we default? And so I feel like these new changes are going to hopefully spur people to kind of get into it, start doing that. And we're going to start seeing hopefully some more data on pushing forward in that avenue. And so I just want to encourage people to still do it, even though it's going to be really frustrating. And like, we apologize way in advance because it's going to be complicated and probably everybody's going to be upset for a while till we figure it out. But like, even though it's complicated, it's just something that's really important that we need more, that we've been talking about a lot more recently in, the energy improvement market across the board. It's like, we need to change our energy dependency. We need to take advantage of this. We need those people who are willing to do it, even when it's frustrating, to kind of move that needle. So just some encouragement out there for people. It's going to be complicated. I'm sorry.
It always feels. Yeah, it feels almost like the 90s when I first started designing, when they changed from the 3.5 gallon flush toilets to the 1.6 gallon flush toilets. And the rule came out before really the things were 100% dialed in, where they got over their skis a little bit. And I'm looking at this going, I don't know if technology we're going to be over our skis like we were at the toilets, but I think just in the understanding of how we're going to navigate this, we're going to be over our skis a little bit.
And I hope that it's going to teach us a little bit more about resilient systems too, right? Because that's part of, that's part of this thing is like, you've got this system and you want to upgrade part of it to make it more efficient, but you got to take the whole thing out now because this part doesn't work with this part and it doesn't have the same this or that. And it's like, we're in so many ways not building resilient systems. And so hopefully that's going to teach us a little bit about this too. Like, we're starting to think about that in our buildings. Like, once you take it apart, what happens? How does it, and how does it handle these climate changes? And how do, what are we doing with this? So it's like, hopefully we're going to see some of that in our mechanical stuff as well.
It's interesting. Like, my brother is a great example. He lives up in Western Pennsylvania, and he's got a newer air conditioning system, but he's got an oil furnace because it's an old house, right? And we don't have them out here. It's rare to have oil furnaces out here on the West Coast, but there it's common. And he's like, hey, I think I might just put in, natural gas or electric heat. And I'm like, well, you might wait till first of the year because there's going to be one rebates. And you just got it serviced and it's working well. So it'll probably be better, but we don't really know how this is all going to, it's probably going to be February, March before you really get an idea of even what those things are going to dialed in and be, because it's going to be a little complicated.
Right. And so this leads into a totally off track,
Yep.
but I'm going to talk about it,
Cool.
which is, that's one of the things that comes up about renovation. There's not a ton of renovation stuff in the original Pretty Good House book. Apparently we're going to maybe have a follow up with renovations, just, little plug, might happen. No promises, but, we need to move away from fossil fuels, but that doesn't mean that we need to all of a sudden just take everything that we have and junk it, right? So I'm reading this book. It's 10 years old already, but it just came across my knowledge, right? So there's things out 10 years called Garbology, which is actually talking about what happens to our trash.
Mm-hmm.
Like, where does our trash go? What happens to it? All this stuff. And even it talks about recycling too. And they did this project, and I don't know if they're still doing it. And I need to look it up to see if they're still doing it. But they did this project where they embedded trackers in the trash and recycling to see where it went and like how long it took it to get to certain places.
That is so cool.
Right. And it was like this fascinating thing where sometimes recycling doesn't make any sense because we carted it 10 times across the country before it ended up in whatever its final resting place was, which will never offset the actual recycling of these things. So I do want to encourage people back to bring it back home is the right answer isn't always to take out your existing whatever you have that's working right now and just junk it, right? Because it already has a carbon impact. It's already there. You got to recycle it or throw it in the trash, right? The trash is like a whole nother environmental thing that we don't talk about, right? It's like you put it out for the curb and it's like, it's gone.
It's forgotten, right? It's like, out of sight, out of mind.
We don't talk about the 102 tons of trash we make in our lifetimes or whatever. Like, I mean, it's just you the example they use in the book is like, you look at the hoarder house and that's like the stuff that they just didn't send to the landfill. And that's all of us. They just kept it in one place. And so you think about that. And then that's kind of almost like an impact of like, oh my gosh, if I make that much trash, right? And it's really apparent when it's all in one place. But when you're just like, put it out to the curb, like gone somewhere else, it's, set it and forget it.
Okay, Emily, mind blown right there. Mind blown. Hold on.
Mind blown.
Wait a minute. The only thing is between a hoarder house and how you and I live, in theory, is that we just moved it out to the curb and they just kept it in the house.
Right.
Wow.
The only difference between that is, and in some cases, people collect things. Not everybody collects a lot of things. So, there's a little bit of escape in that. But essentially, it is the same, right? It's like you didn't get rid of that trash. And so you just have a visual sight of what all of that is. So if you could just see all of the mountains of stuff that you like put out and sent somewhere else, it's like out of sight, out of mind for sure. And it's like, oh yeah. But so in renovations, our answer isn't always like deep energy retrofit sounds so great. But if you're taking off a whole bunch of stuff that you're then sending to the landfill, can't do anything with, maybe still had a life. We don't have local recycling. So even if you could take it off and somebody could use it, if you don't have somewhere local to recycle it, it ends up in the landfill or it uses a ton of energy to get to wherever that facility is. Like I think it was, can't remember if it was batteries or cell phones or there's some like one e-technology that people were talking about. There are 6 plants that recycle them and they're all in China. So anytime you want to recycle it, it's got to get all the way back to China. So it just uses a ton of our carbon, energy, transport, all that stuff to get it to the place that it needs to go because we don't have a lot of local ability to recycle electronics and e-waste. And, who doesn't have a pile of, okay, so say you didn't recycle it because you were afraid of what was on your cell phone and getting those pictures back. Like, who doesn't have a pile of cell phones? Like,
and chargers and covers and all of the rest of the stuff,
Exactly. So anyway, that was my totally like completely off the wall thing here. But when you're talking about renovations, keeping that oil boiler until it literally can't be fixed, repaired, or anymore. Because if you've got to make a heat pump and you got to charge a system and you've got to do all of that, you have expended some of your carbon budget before it ever gets to your house. How many years of running your oil boiler does that have to happen? And the next 10 years are really important for what we're doing.
Yeah.
So we just have to weigh that balance. It's like, and people ask me all the time, like, well, what's the right choice here? Well, in renovations, it really depends.
Yeah.
It really depends. There's a lot of factors. And unfortunately, that's the part that's super challenging for homeowners to evaluate what is the right decision.
Well, it's interesting. And just to kind of jump onto what you're saying there, this makes sense because I have done some interviews in the past with people that are in the recycling business, the people that are grabbing it curbside and taking rid of it. And they're like, yeah, there's times that we send semi trucks worth of plastics because it costs us more to recycle it. And it doesn't make sense to send it over to China or whatever other country that's doing it. It's actually better for us to haul it over to the landfill and bury it than it is to ship it all the way across the world and get it there, because literally you're spending more in fuel and doing more in damage from the fuel of that ship that's running fuel oil going across there than you are by recycling it. And it's a tough argument, right?
It is a tough argument. And at the same time, we're not held responsible. This goes back to the curbside and forget it. It's like, we're not being held responsible, us manufacturers, the people who are using it, for our disposable society.
Yeah.
Right?
Yeah. And it goes into remodeling as well. So let's say we've got that 1910 2-story cool house, it's fairly unmolested. Somebody hasn't came in and done 4 flips on it. It's got plaster, and all of a sudden people are like, we're going to make this all energy efficient. And now all of a sudden they've got 4 dumpsters full of plaster, vermiculite, horsehair, whatever else I jammed in those walls back in the day, depending on who built it, where they built it. Lath and plaster, all the trim. Really, does that make a lot of sense?
Yeah. And it's so frustrating to me. So part of the design aspect of the Pretty Good House book is to build things that people want to keep and build them for resilient systems and to build them for future remodeling, because we know people are going to remodel it. So what happens to it when it comes off the house, right? Mm-hmm. Like everybody's like, oh, I want vinyl siding and no maintenance. There's no such thing as no maintenance.
Doesn't exist.
And, vinyl siding is going to have an end of life, and then it's going to go to the landfill and it's going to live there, or they're going to incinerate it, which is terrible too, and so we're going to think about where does it go when it gets to the end of life, and how can you deconstruct it, right? Like, how can you take these houses apart easily? Like, can you take the cellulose out of the wall and spread it on the ground in your grass and have that just be perfectly fine? Like offcuts on wood siding here. I've got a project site. I don't think they've had a dumpster. Mm-hmm. And because almost everything, it feels like, is wood on this project site. And they have this dumpster, or not dumpster, it's a wood pile, mm-hmm. but it's in bins. And they have all kinds of funny things painted on it. It's like, please take party wood and like campfire wood and like wood stove wood. Like, they wrote all kinds of funny things on it, to encourage the neighbors to take it, to, put it in their wood stoves, or, hey, like, you're camping in Maine for the weekend, here's mm-hmm. some kindling or whatever. And so it's just, they could have just thrown it on the ground too, and in a couple of years it would have decomposed into something. I'm like, that makes you feel good about what you're building versus like you show up and you have 4 dumpsters. That does not make you feel good. Yeah. And I agree that sometimes you might have a material that you have had friendly critters who have come and lived mm-hmm. in your structure, and that you can't put that back in other stuff. Exactly. I get it. But you can spread it out and fertilize the yard, depending on what it is.
Well, it's interesting. I had a conversation with Keen Utility, and they did their new headquarters here a few years back. And I mean, it's multiple stories. I think it's 4 stories, like a city block in Portland downtown. And they hauled off like 1 dumpster or 2 dumpsters out of the whole building. Everything else was reused. They repurposed. All this stuff got reused or donated and was used someplace else. And so I love it when, of course that costs more money, right? I mean, it always costs more money because the cheap answer is to back up the next dumpster.
Well, wait, it costs more money if you only think about upfront cost of doing it. But if you were charged for all the other things, then no, in the long run, it really didn't cost more money.
Exactly. But you know how it is with construction. Someone's looking at the budget. Oh, yeah. What am I writing the check for today is what they're worried about. And that's one of the problems we're into. But let's talk about your book, the Pretty Good House book. This is fascinating to me, what you guys did, because I honestly haven't seen a book like this out there before, where you guys just jumped in and did a very intelligent deep dive that I think is really smart for people to jump into if they're just getting ready to design a house, remodel a house. All of those things this is an important book.
So the book was really meant to, one, be homeowner approachable, right? Because these are the people who want to understand what they're getting, or who may think that they are getting this anyway. And so it's a conversation for them to talk with their design and build team while they're building or designing a house. But it's also meant for people like when I was in architecture school and just getting out and starting as a young architect, I didn't know what I didn't know,
right.
And like, I love some of the great resources that we have available to us, especially those of us who love to get in the weeds and get down and, all of that. But that is too deep of a dive for a lot of people. And, if you've ever met some really nerdy building science people, we're going to debate 6 different ways to do it. And then we're still going to do it the way we would have done it originally, but we got to talk about all 6 ways, right? So,
oh my gosh, this is so right. There's the elephant in the room right there, right? That's the elephant in the room. That
is just how it works. That's just how it works. And so anyway, you get onto some of these great resource sites and you run into us, right? And we have 6 ideas. And now if you don't know enough about what we're talking about, you're totally confused and you quit. And you don't do any of it. And so the point of the book is to be really approachable for both homeowners who are thinking about building or renovating a house. It's also supposed to be a great first place to start for newer professionals or professionals who maybe they've been building for a while, but as codes are getting more strict and we're getting a lot more products on the market, and they just want to understand how these things relate to each other, it's a series of guidelines. It's like, hey, did you think about this? Did you think about this? And like, no, you don't have to sacrifice the performance of your building in order to save money. Here's what you need to do during the design process to evaluate the economics of that, especially right now where, it can be hard to get some products, or it can have long lead times. Like when you got to order your windows 3 months before you're going to break ground, that's kind of scary for people, right? And so it's just a really good broad overview. And it's not a system. It's not Passive House or LEED or Energy Star. And you can have a pretty good any one of those building certification houses, right? Like Passive House might be the economic level that you go to, right? Yeah. And Pretty Good House is in tandem with that. But you know what? Economically, maybe you can only afford to build to code. And it doesn't mean that you shouldn't think about potentially changing some materials for indoor air quality, or everybody needs to have mechanical ventilation. Let's stop kind of ignoring that part of the code, right? There are some places in the country that are better about enforcing it. But then there are other places in the country, which interestingly enough, I heard the story when I was in Kansas City, where there are lots of places that say blower door testing is required, right? Sure. And lots of us do blower door tests. But then the code office doesn't have any way to record that you did a blower door test, right? So there's no way to prove that you actually did it, right? And so as professionals, we can get a hold of that. Some towns will keep it and they'll put it in the building file, but we have all been in a building department where the building file is like 1 page and you're like, where's the actual information on this project? And so, there's not always a lot of ways to kind of keep track of that. And so it really is encouraging you that maybe code, and some places code is almost as good as Passive House. Like code in California and Passive House that works in California, almost neck and neck, right? I mean, they're like the same thing. And we're trying to, explain to people that the code is done by people who have practiced in a lot of areas and made intelligent upgrades for people to do. So, code is not the enemy. Like, let's start forgetting that it's an enemy. But Pretty Good House is a spectrum of everything in between, and it talks about economics because there aren't things that you have to do. There are just things that are better practice that we want you to think about doing, right? do you really need to build that guest suite for another $60,000 to $80,000 that somebody stays in once a year?
Hotel's pretty cheap.
That's like 350 hotel rooms or something stupid. Like that's 350 years to offset the cost of just having built that, right? Not cleaning it, heating it, keeping it free of things that we accumulate in our houses because our spaces are bigger, right? Just starting to talk about what do you really want out of your space? And hopefully kind of leaving.
I've run into this with homeowners with children. They're designing this whole space for their 9-year-old. And I'm going, you realize by the time this is done, they're 10. And by the time they're 12 or 13, that's going in the dumpster. They don't want anything to do with it.
Right.
You're building for a year or two.
Or you're building for that one day of a year, right?
Exactly.
You're building for that one day a year. You got to get a giant Christmas tree in the door. Like build for the other 364 days of the year that you're doing it. Like that grand staircase because you have a guest that comes over like once a year that you want to impress. Like you still have to heat that and light it and do all kinds. Like it's a circulation space that you use so infrequently, right? And yeah, sure, grand staircases are beautiful, but like they can also be beautiful, functional part of another room. They don't have to be like this. And those spaces always add other weird spaces, right? You know, trying to explain to people that it's like, yeah, I have this, but now I have to get from here to over here. And now I've got this hallway, or I've got I always love the grand staircase with that weird space at the top of the stairs, right? Well, it's not really big enough to be a room, but it's not really small enough to be a hallway. And you're like, what happens in this space? Like,
So you can't use this in a home office because the kids that are up there in the other 3 bedrooms are running around. So you can't have a Zoom meeting in that space. You really can't use it. And then my favorite too is the big grand circular staircase that comes up and sweeps. But now you've got radius walls downstairs in all these different rooms because that wall now ends up creeping around on the back side of that. So it's the same kind of thing. But I wanted to touch on this with building code, and it's fascinating how well California does stuff, for instance, down there. But then I'll drive by projects in California and go, you put that house wrap on completely wrong and they're siding right over the top of it. So
have you seen, so talking about people who are a super awesome deep dive, and I'm going to promo his book too. If you haven't gotten a copy of Allison Bale's new book, Does a House Need to Breathe or Not? Fabulous. But he just posted, he writes for Energy Vanguard. He's been doing amazing posts for years, and he just posted a new one, right? And I think he actually got a picture from another awesome professional, Christoph Irwin with Positive Energy in Texas, of a picture where they started to put the siding on before they put the windows on, and then they had to take half the siding off because they had to go back to do proper flashing. And then there was a follow-up photo in that post as well where they put the windows in too early and they forgot to put their WRB on. And so in the picture, the WRB is just like wrapped over the window, which clearly they must have come back and cut it and done some flashing tape and some other things. But it's like sequencing being so important and then doing it wrong, right? You drive around all these job sites and you're like, ooh, well, I was driving by a job site down here and they put R5 rigid insulation on the outside. Technically, our building code, if you only read the chapter on, insulation, says that's fine. But if you actually look at the moisture resistance of the R5 in our climate zone and you read, I think it's chapter 3, which talks about condensation resistance, it's not okay.
Yep.
And it's like driving by and going, that's going to be that's going to be a problem. And so, yeah.
Great example. So my buddy he's been on the show before here, Jason McDaniel, he's Global Tile Posse. He's a big tile guy out there. And he went down to help out another homeowner that got taken by a tile contractor. And so, they tore the whole space out. He spent a week down there rebuilding this thing for him. But I think it was Memphis. No, I think it was Nashville Building Code. He did a curbless shower for him. It was beautiful, so they could get access to it. He called for the inspection on the shower pan, which he needed, and they said, you didn't do the dam in front. He's like, it's curbless. He had to build a 4-inch waterproof dam across the front of this, fill it up with water, and he's like, I get that you have building code for this, but if you have 4 inches of water in the bathroom, why does it matter? It's so some of this stuff you just shake your head and go, what is that accomplishing?
Well, I know there are some weird things in it where it's like this doesn't make sense for how you would test it because this isn't how we built it. So we wouldn't do that, but we'll try to somehow mangle together some version of what we have done to kind of answer this thing. Yeah. So like not all the.
Yeah. It's just, sometimes I get the intention of it. Oh, we don't want that to leak. I get it. And I'm sure they looked at it and went, okay, all shower pans have curbs and we're just going to go to that. And so you've got some inspector out there going, well, we got to test it. Got to have 3 inches of water in it. Put
Right?
3 inches of water in it. And it's like, oh, come on, guys. That's the stuff that makes people like you and I scratch our heads and go, I'm not sure what you're trying to accomplish here. Some smarter people need to sit down and go, is this the way we need to do it?
Yeah. So we were doing a project and we, for the most part, if we're going to build new, we usually do super high performance. The building envelope is mine. What you're doing on the inside is yours. We'll put up walls, not put up walls, all kinds of things. And so I submitted it to the code officer and they're like, your wall system doesn't meet code. I was like, say what? So they're like, it doesn't have continuous exterior rigid insulation. And I was like, that's actually not what that says, right? And I was like, okay. I was like, but I'll put on my drawing so it understands. I was like, I'll walk you through how our wall is. Double stud wall. Our continuous insulation is just in the middle. It's not on the outside. And obviously it's not rigid. Yeah. But, it's continuous. There's a thermal break. There's, no thermal bridging in the wall system, et cetera.
It's actually much better than what they're trying to propose.
Exactly. And so then I went through and said, also, there's a chart directly below this that has the UA equivalent. And so here's my UA for my wall system as well. So even if you read this as this is what this says, which is not what this says, this is the other chart that says, and like, the U value for the total wall system through my energy model is significantly less than what's in the chart. And she's like, okay, that's fine. Just put that on your drawings. And I'm like, okay. But don't tell anybody else to do that. Yeah. Because let's not do that.
Yeah. Well, maybe that was the same person that was over there putting the foam on the outside of the other one that was like, you got to do this,
Wasn't in the same town, but maybe. But you know what I mean. I think that there's a very real possibility that lots of people said that because that was how they interpreted it. In a similar problem. So we also do a lot of shoreline zoning because Maine has a ton of water. Yeah. So anything within 250 feet of any major water body, we've got a lot of lakes, we've got a lot of streams, we've got the ocean. And so I was working on a project and they were, trying to tell me what the expansion rules were. I was like, oh, that's not what that says. And she's like, what do you mean? And I went through and I was explaining to her and she's like, oh, so she gets on the phone because they had just learned about it. They had just changed the shoreline zoning. Right. Yeah. I get it, and they get on the phone to the person who instructed them and they were like, is this what this says? And they were like, yep, that's what that says. And she's like, hey, it was great meeting you. I have a couple of people to call.
Oh, no.
Okay. That's probably a good idea.
Firefighting 101. Oh, no.
Oh, no. But I mean, at least they were willing to follow up with, whomever they had and just said, hey, this is, I misinterpreted what this said. It really says this. And it can be hard. There's a lot of jargon in it. And I think people give up on that and it's meant to be easy. And so if you want to know more about code, I also encourage people to get on TikTok and follow Glenn Matheson. He is the only person I have ever met who makes code interesting.
Nice.
And he has Code University and he explains a lot of things to people. And so he's been at a bunch of these building science symposiums, just talking about, the origin of code and what's in it. And I don't know anybody that knows code the way that he does.
Awesome.
So it was actually exciting because normally you're just like, oh, I don't want to learn about that.
Exactly. Well, it's fascinating with code because, there are some states that do it so well. And then there's others. I talked to somebody that's, in our audience that's out there and I'm like, oh, that's right. You don't have ventilation required in your house as long as there's a window in the room. So you don't have to put a kitchen vent hood if you've got a window. You don't have to put a bath fan if you have a window. And I'm like, this is such a bad idea.
Which is super scary to those of us who have been, sort of in the high performance world is, we argue with our clients about having oversized range vent hoods because we know the importance of the capture area and all of this stuff. And then you have people who are putting gas ranges in with no hood at all. So not only are they not picking up on any of the VOCs from our cookware or burning, like, I don't know about anybody else, but I like to burn things when I cook. Yeah. Whatever you've burnt, that all has VOCs in it. And then, water vapor from what you're cooking, but also too, now here's this gas range. Oh, by the way, you've got carbon monoxide, which is tasteless, colorless, and odorless. And you don't know you're poisoning yourself or that, super scary. And so, I'm really big. In fact, if you have a gas range, you have to have makeup air too, because the range hood, needs to be so large to make sure that you're not poisoning yourself.
Well, my house is an example of that. Yeah. I've got a 48-inch gas range. So it's 6 burners and the griddle, right? I've got a 1200 CFM hood, and I use all of that when I have on the griddle a steak or something on it. Otherwise, the house gets smoky.
Right. So it's so important for people. And I didn't even touch on bathroom vent fans, which is what's the largest point source moisture in your house? The bathroom. How many people have mold growing on the ceiling? And by the way, till you see the mold, you already have fully saturated and a bigger problem than you thought. And when I worked for a little while doing energy engineering projects for low income housing as well. And, the number of those that you go into because somebody doesn't want to report that the fan is broken or that they didn't use it or whatever, that have mold in them. It's just because you get into a lot of different units, you can see it on a larger scale. And it's hey, this is so incredibly important. One of the things that we did as part of those projects was try to do education with the homeowners to say, hey, look, I get it. You maybe don't always want to report if something's broken or, the fans sometimes are loud, but this is why you need to use it. And this is how it impacts your health. And just try to, help people to understand why that's in there. It's not just in there because it's steamy in there and you need to use the mirror after you take a shower. Has a big impact. You need to use the bathroom fans. Or up here in the Northeast, at least for a little while, we have done some where we use our ERV in the bathroom to recapture some of that moisture, because trying to get houses to 40% in Maine at negative 15 degrees, pretty hard.
Yeah. Dew points are kind of in a weird spot.
Yeah.
Well, it's interesting, and it's so crazy. 15 years ago when I was designing kitchens, 20 years ago, I was using in each bathroom, the Roburn medicine cabinet with the heated mirror. I have a steam shower in a fairly small bathroom, and because I put the fan in the correct space and have a fairly large fan in there, that mirror has never, ever been foggy. And I can open up the 3-foot wide door in the steam shower and leave it open. And unless the steam unit's on, it's getting sucked up. So, and those are things that are so simple to do. And now what I'm so excited with, and you and I saw some of this last year when we were in Orlando at the big show down there, is companies like Newtone, for instance, they're coming in and now they're getting it so that ERV can now talk to the bath fan. And there's sensors in the house. And we're really starting to get it where the homeowner and the user doesn't have to think about it. It can start doing it for you. And that's pretty cool.
Yeah. So we were on the tech stage together at the International Builder Show, and we talked about all kinds of fun, cool techie gadgets. So this year at the International Builder Show, I vote we have a little competition to see who can find the coolest gadget on the show floor.
Game on.
Game on, right? I am totally into this idea. But somebody said at one of the conferences that I was at recently, raise your hand if you'd be willing to give, your homeowners an indoor air quality monitor afterwards. And I'm raising my hand, yes. And it was funny because we had this whole discussion. You had the carbon monoxide alarm, which in a space like that would just go off consistently, right? Yep. So we had it disconnected. But generally speaking, if you do enough education with your homeowners, it's not as important about what the numbers are, right? The accuracy on some of the home monitors is kind of we're not in a testing lab, right? We just want you to know when something is off, right? If you have a spike in something, that might be some kind of indication of something else, right? So, we actually have been doing a renovation project at our house, and we had to put down some Advantech flooring to replace some sections of 1970s particle board that's mostly just sawdust.
Yeah.
You know,
It's like dried oatmeal, right? Yeah.
It does look like dried oatmeal, you know, and you hate to pull it up, but at the same time, like it's not doing what it's supposed to do anymore. And this is in renovation when you should take advantage of when products are at the end of life to do better things. But anyway, put some Advantech in, see a spike on our energy monitor. Because guess what? Advantech has glue in it. It's got other, you know, it's got other stuff in it. And so we see a spike in it and we're like, oh, I wonder what that was. Well, we finally put down some wood flooring. Guess what went away? That spike. And it's like, oh, yeah, right. It's been, you know, we didn't have the windows open when we were doing it because we weren't thinking anything. Well, like we weren't really thinking anything about it. And, you know, for my chemically sensitive clients, we go like the whole route. You know, we wouldn't have been that. But, you know, neither my husband or I have, you know, severe chemical sensitivities that we knew of. Right. So we were just kind of doing some things that are great products that you put down and that you use. And I went, okay, right? Like maybe you have to think about this. Now, neither of us had an issue with it, but the energy model, you know, the monitor, the indoor air quality monitor was saying, hey, something is going on here. And it was just a trigger to take a look at something, you know, and that's what we want. And one of my clients, I did a walkthrough with them. We were going through their systems. Do you know how to use this? Do you know how to use your ventilation, your heating, whatever? And I left. And because we had been talking about it, they called me afterwards and they said, hey, you know, I can't seem to get the moisture to leave our bathroom, even when we're running the bathroom fan when we're doing a load of laundry. And I was like, I'm glad you asked. Do you have a bunch of lint in your bathroom? And she said, yes, you know, we do. And I was like, your dryer vent isn't connected. So the reason that you have to continuously run the fan and it's wet in here is because somehow,
moisture.
Probably when it got pushed in or whatever, it got disconnected. And I was like, I'm so glad we had this conversation and you called me because that could have been a much bigger problem. You know, the heated byproducts of laundry detergent, not so great to breathe in. And that kind of excess moisture, like you think about how wet your clothes are when they went in the dryer, all that moisture is just in your space. Like, hey, do you still have this in Portland, Oregon, or is this just like a weird Maine thing where they would just drop the dryer vent into the like bucket, right? And so it would collect the lint and the water in the bucket. Because they were trying to recapture the heat. And I'm like, you might have recaptured a little bit of heat, but you created a significantly bigger problem with like water than what you had. So like, don't do that.
And then the worst thing is if it's a gas dryer, right? Because that's also putting out all that carbon monoxide back into that space when you do that.
Right.
So that's even worse.
It's like, you know, I want them to have an indoor air quality monitor and I want them to call me when there's a spike on it. And unfortunately in the building world, sometimes those investigations aren't really clear. We had one client that just had a major reaction to her house right after it was built. And we think that something was off gassing. Like even if you ask for low VOC paints, once they tint them dark, they don't always use low VOC in the tint, even though you ask for low VOC paint. So you have to know what you're asking for. And so we think what happened was that maybe either the thinner or the tint in the paint might have, we painted the basement ceiling. That was where she had the most, you know, reaction
maybe
to it.
Maybe it was the primer. Maybe it was the drywall, right? I mean, you're chasing
maybe it was the primer. Maybe it was the drywall. Maybe it was this little piece of foam we used in one location. You know, maybe it was the, you know, and we tried to do the best that we could with like the cabinetry that we got and the flooring that we got. And they brought furniture that they had owned in their other houses too, right? But like, here's this high performance house and we're not really sure what the trigger is.
See, that's one of my biggest speeches I've given to builders that are building high performance houses is that before your homeowner moves into that house, you should do a full air test in that place. So you know what's in there, because that way, when your homeowner moves in and they just got that, maybe it's an IKEA couch or no shade thrown on IKEA, but you know, whatever's in that foam or whatever's in brand X's foam, It could be
not
anything.
even IKEA, right?
Yeah.
You can have nice high-end furniture companies that have stain guard on it, right?
There you go.
Like if you're asking your product to do something that it doesn't seem natural for that product to do, then there is something in it that is helping it to do that, which in some cases might be a perfectly natural material.
It could be wax.
In a lot
It could
of
be
cases,
something like that. It could be simple, right? But it might not be.
But in a lot of other cases, we just have a ton of, made products that are chemical compositions of some things, so the whole BPA plastic. And then they were like BPA free, but they replaced it with BPF, which is the cousin of BPA, which is actually just as bad for you. So,
yeah. Well, okay. So here's a funny story that's at my house. So this is a personal story. I put in this really great air system. And Carrier Infinity, I have no problems with that at all. It's working really well, variable speed, super efficient, zoned in my 1970s house, so it works great. I put on as an add-on to it an air scrubber. And this air scrubber is working too good. And Eris is the one that makes it. It's really nice. Problem is Julie, my wife, can't sit there and bake bread because if she goes to make something rise, it kills the yeast in her dough when it's sitting there on the counter because of the peroxide things that are in the air and killing it. So in the summertime when she made bread, she had to take it outside and put it on the outdoor kitchen because it wouldn't rise in the house. And so now I'm going, I don't know if I'm going to keep that technology now. You know what I mean? And that this is where I start getting concerned that if it's doing that to the bread.
People like us, right? We're the people who trial it all, right? Everybody says, I want to go to the architect's house. No, you don't. No. It's an experiment. It's an experiment in all kinds of things that we're trying and testing and who knows what we're doing, right? And so just like that. But it does make you think, right? And I think people sometimes worry about things that aren't actually an issue. Like there are mold spores everywhere and a lot of it is not toxic and it's not harmful and whatever. It's the bad stuff that you want. And like you hear mold, you think bad, black, terrible mold. That stuff is bad. You need to do something about that. But like you said, it kills the yeast in the air. Well, if you're a beer fan and you're making lambic, that's how they make lambic, by the natural yeast that's in the air. And so you know what? It probably isn't terrible for us. Yeah. Now, there are some things that are bad for us, but we don't want to kill all the germs and biodiversity. Like we need those things too. It's have you ever heard me go on my diatribe about grass and pollinator plants, right? Like we need bugs, which includes the tiny microscopic things that your air scrubber might be killing. It's the same. Another thing that I think that we need to spend a lot more time talking about is water quality.
Oh my gosh, right?
And the things that we use to treat water can sometimes be worse for us than whatever it was that was in the water. Like obviously not radon, but you were talking about that, like RODI water is not stuff you should drink, right? You got to add something back into it. There's all this. So
and most homeowners go, oh, I need a water system. They jump online or go down to their home improvement store and put something in. No one's ever tested the water. Nobody has any idea what's in there.
Well, even so, we live on city and town water, right? Yeah. So this is tested, right? Mm-hmm. This is highly tested. Yeah. And we were having trouble with some of our fixtures, right? And I was like, well, let's just put a filter on it because you don't think to filter town water. Well, guess what? First day we had it. Completely filled the filter with copper. I mean, so much copper filing in it. Completely clogged the filter first day. So I call up the water department and I was just like, hey, I put on this 5 micron filter on the water system and like it is chock full. I was like, it's green. It's not slimy. I know it's not biological matter. I think it's copper, blah, blah, blah. And she's like, I've never had anybody have a 5 micron filter on it. Like they sell them at Lowe's.
Yeah, this isn't rocket science here. Yeah.
Clearly somebody does. And I was like, and, she's like, well, it's not us. It's probably in your water line. I was like, this thing is a whole house filter. Like it's on directly after your pump. So the only part of it that's coming in my house might be from like...
It's 30 feet, right? Yeah.
I mean, even 30 feet, if you count, do I own that part that's outside of my house that goes to the water main? Like if I don't own that part, I'm talking like
from the
3
meter,
feet.
whatever the meter is. Yep.
you're 3 feet from the water meter to where this thing is.
That's right.
That's it.
In your area, your water meter is in your house, so it doesn't freeze. Mine's 150 feet out towards the road.
Oh, yeah. See,
and 18 inches down. So, yeah, different climate.
A little bit closer. Right? This is we talk about climate zones. So we do talk about this in the book. Yeah. Not that we were off topic with the book, but climate is so important when we're talking about it. Both, there are 8 climate zones in the United States, and then there are microclimates in your site within your climate zone, right? If you're on the side of a hill, you're going to have a different climate on a different microclimate on your specific site than you're going to have in other areas. And I think people totally disregard this idea of climate zones. And part of the reason why I think that is because people will come to us and they'll say, we found this plan online, we love it. And I'm like, great, the house is perfect in Florida. But by the way, here are the 8 reasons why it won't work in Maine. Yeah. Or why I can give you something that looks like that style, we can copy that style, but here's the structural that you're going to need with your 1.5 12 slope to hold up 90 pounds of snow load. And so, I think that's disregarded. So that's in the very first chapter of the book, I think, which is start with your climate zone. If you can't afford to have a fully custom house, pick a plan or a modular company or somebody who's designed something specifically for your climate zone. And there's so much architecture out there today that there's a style that fits the style that you like that has been designed for your climate zone. But if you bring me a plan from 2008 that was designed for, your climate zone in Portland, I'm going to say, I can custom design you something that looks cool in that style, but I can't give you right? This.
But not that.
You can use that as style inspiration, but I can't give you this. And if somebody tells you they can give you this, you're going to freeze. It's potentially not going to hold the snow load, and you're going to have a lot of figure it out in the field to accommodate for things that aren't planned for in this. Yeah. And that's going to cost you money.
Yeah, it's absolutely the same. And it's funny. So I like wine and I go out and talk to friends at their wineries, and I'm out there enjoying it, like beer too, but I'm out at the wineries and they're like, oh yeah, well the climate zone over here for this grapes make it taste different on the same piece of property than up here. And think about it. Right? Okay, if that's enough to make the grapes taste different, what's it doing at your house as well? And that's within a quarter of a mile.
And you talk about grapes in the climate zone, you probably also have different soils too, right? So it's so incredibly important for you to have a building site before you have a design so that you really can make these things work together. Even if you're using a pre-designed plan set, you need to evaluate that for the site. You may need to do geotechnical. I met a phenomenal architect in the Chattanooga area, and they had this piece of property, and then the drainage ditch next to their house, the town decided was a stream. So then they had to have a 30-foot setback. And then they get into digging and they had to do, I think it was something like a 6-foot deep French drain under their house because of the drainage in this area, right? Those things are critical. They're important. You got to think about it. And unfortunately, a lot of times if you don't think about that, they're going to build it high up out of the ground and they're going to bring in fill to fill up to it. And that just kind of goes against everything that seems natural about working with the landscape.
Yeah, we had to on a project I did 15 years ago up in Seattle on Lake Washington. Beautiful house. Had the property, designed the house. Geotech went out there and went, hey, you need 75 concrete pilings underneath the structure to hold it up because the soil is not going to be good because this is all just, you
basically need like one solid concrete piece here.
And they were out there for months doing the geotech work just so they could start on the foundation stuff.
Yeah.
And of course, David Applebaum comes on here and talks all the time of the my good friend architect down in LA where he does stuff in, Beverly Hills and Bel Air on the hillside where they've literally got to strip all the dirt off the hill and put something in there that's going to be more stable just to be able to put something up on it.
Oh, does he work in all those places you've seen in the news right now where essentially the whole hillside is just like, bye-bye house?
Yeah, So he does all those. He's the architect of the stars down there. And he is so amazing with the celebrities. He's the celebrity guy, So he's doing the 40,000 square foot house kind of stuff as well. So he's doing all that. But
That's another thing the Pretty Good House book is not. We do not understand the 40,000 square foot house. We're not sure what you do with all of that space. I guess if you have an unlimited budget, should you still spend that big of a carbon budget on it? Especially in areas like California, right, where you got a lot of geotechnical stuff, right? You got a lot of concrete and steel. Well, guess what? Concrete and steel, real high up there on their carbon impact. And so Pretty Good House is maybe for the rest of us, right?
Well,
who live in these 1970s, 1,400 sort houses.
Well, that's me. Yeah, exactly.
That's me.
Yeah.
That's me too.
And it's funny,
So,
when I look at this too, is kind of a twist on what we were talking about here. There's some companies now that are starting to do these modular homes that are coming out interesting. I just talked to somebody down in Texas that are doing high-end, really about as green as you can build it that I've seen. And they're affordable too. I mean, you can get the house placed on your lot for, $300,000 and, level 5 finish on the inside. They've got and the advantage that they have there is that they can actually build it indoors. So you don't have all this lumber that's getting moldy in the wintertime or anything like that. So it's kind of interesting to see how some of these guys are doing some new stuff.
And I think this is an incredible important piece that you're putting here. We did a whole section, little piece in the book on, this, but I think the future of really sustainable building, obviously designing one single family house at a time is not going to have as big of a climate impact. If we're going to do it, we should do it well, right? Build better things. But I think the modular industry actually has a huge potential to have an impact on housing at a much larger scale. One, because they build the same house over and over again, right? They're not recreating the shop drawings. They're not doing all of that. But two, when you work inside all the time, you're not getting paid to run your own business and run your own trucks and do all that stuff. So the more things that they can do in the factory, the better they can do. They also have better buying power, right? If you're building hundreds of houses a year, you're going to get a better price for buying certain types of materials. It can really push forward some of these better building standards, and we need them to just do it as a matter of principle, right? Like, let's stop building the stuff that isn't really good enough for the populations that we're serving, because you have the ability to do it at a cost-effective price point.
What I love too is waste. Yeah, the waste is what's amazing, because now instead of taking a 16-foot 2x4 and having to cut it to 14 feet, they can order 14-foot material. They can order, if they need to have, if they're throwing away half a sheet, they can order a 10-foot sheet of OSB. That you're not going to order a unit for that, but you can now do that. So the waste is amazing coming out of those places compared to a normal job site.
Well, and if you look at how they have it set up, some of these really well organized ones too, all those offcuts go into the pile to become blocking in the same thing. It's like, this is less than 3 feet. I need one that's less than 3 feet. I go to the 2.5 foot bucket. I got a piece of blocking, right? And so there's so little waste in really well-run factories, and they set up these systems, right? Some of these great ones have, they have the same bin at every station, right? Yep. So that you're not running all over trying to find, the box of screws or GRKs or whatever it is you need at that moment. Like, here it is, it's here, and so it's efficiency in a whole new way. In a lot of these places, when I talk to product manufacturers or distributors too, we're talking about, well, how's your factory run? How are you powering your factory? I mean, I love it when I see a solar array on top of it. Sure. It may not make enough power to run the entire factory, but hey, if you're offsetting a significant portion of that, that feels good, And, there are some product manufacturers who recycle the water that they use in the process and, use it again, right? Well, we're seeing out on your coast, we're seeing huge water shortages. I mean, I think it's been 5 or 6 years, or maybe even 8 years since I was out and saw Lake Mead, and I thought, gosh, that's low. And now you're seeing all these stories where that
was high compared to
they're finding bodies from the 80s. That's that's when it starts to freak you out, right? It's that low that things that someone thought was submerged in hundreds of feet of water is now like on the beach.
Well, and the other thing I think that's really important as well with these modular units now is that quality control. You can have somebody there that's watching the entire process. I'm sorry, a job site does not have somebody sitting there watching every nail go on, every screw go on, everything go together. Those processes of watching it aren't there because one Friday afternoon, there's a framer hanging around till 7:00 at night because he's got to get caught up because they're a half day behind, or somebody comes in on Saturday and is knocking something out to keep on schedule. Things get covered up, things happen, and you really eliminate a lot of that when it's a factory built piece.
Well, and you think about it too, right? One of the biggest challenges for some of these job sites things is lay down space, right? You don't have anywhere dry to put something to acclimate it, right? So everything that you put into the structure is basically wet, right? Gets rained on, could be soaked, right?
It turns black in my climate here when they're building these 4-story mixed use stick frame projects. By the time they're sheathing the roof, floor 1 OSB is black.
It's black. And like, you just hope that it was able to dry out and that it, it's good before it got enclosed. But like, they're working on timelines, stuff's getting enclosed, things are getting enclosed wet. Do we understand all the building products that we're putting on our building to the extent that we know that it's allowing it to dry or allowing it not to get wet? Well, what happens if it was wet when you put it in there, but you have a system that's meant for it not to get wet, right? So in the factory, generally, they have a big space, right? Like the 2x4s you're using on this project probably didn't show up yesterday.
Yeah.
Like there's a whole stack of them. Maybe they did. I don't know. Sometimes right now it's hard to get things, whatever. But like they can be in there. They can acclimate. They can have these systems set in place so that it is straight and it's dry and it's, installed in, to a 32nd of an inch. Like nobody in the field's cutting things to a 32nd of an inch, right?
It's just not happening that way. So that's the cool part. And they have jigs and all that other stuff. And when things get tipped up, they're tipped up correctly. They've got a crane that's doing it. It's not 2 guys trying to do it that are getting hurt and bending the wall up and it's all out of square. I mean, it's completely different. And the impact there of, you're putting in, they're doing, it's Texas, so they're doing slab on grade. They get that poured. They come in with the crane and lift like the kitchen section, the living space and the bedroom. Those are all separate sections, assemble them together and off they go. And this isn't like your double wide, single wide, triple wide stuff. This is, when it's done, it looks like a custom home. They level 5 finish on the inside, stucco exteriors, metal roofs. I mean, they're built to last, which I like.
I'd like to see us doing more of that. It's funny that, everything inside your house is probably built in a factory except your physical house. A lot of that is still stick built.
Yep.
And there are some challenges to that. And it's not always more cost effective, right? Especially if you're trying to ask a manufacturing facility to build a custom structure. Sure. They haven't built it before. They got to build all the shop drawings. They got to run it through engineering. They got to make sure, like those things don't make sense. But where not everybody needs a custom house. They need a house that works for them and their family at the time. And, they say we move every 5 to 7 years. So why are we moving to a structure that we then blow apart and do all these different things for? Like, let's stop building the same thing over and over again. Like maybe when you move from that 2,500 square foot house, because all your kids went to college and they're at home anymore, you move to the 800 square foot house, which doesn't exist because nobody builds them. Yep. So let's build those,
so smart.
Not everybody wants 3 bedrooms, 2.5 baths, and 2,500 square feet. Like we just don't all want that.
Emily, where has the time gone? You and I could do this for like another 4 hours and just keep rolling, but I know we have listeners.
That was 5 minutes.
I know it. So how do people track you down and get this book? Let's get to the book first. How's the best place for people to find that?
So the best place to find that is to go to the Taunton bookstore and put in Pretty Good House. And since I'm going to call this an event, a podcast, if you use PGH event in the Taunton thing, you're 25% off of the book right now. So buy it from the Taunton store. I highly encourage you, if you're listening and you're a professional in the field, get a couple, hand them out to everyone in your office as Christmas gifts, right? I like wine too, Eric, but not everybody likes to give wine to their clients anymore or to their staff. And so, hey, you know what? This is an awesome book. It's a great coffee table book. It's a great book for your staff who are just coming on board, new people in your office. It's also a great book for your clients. It helps them to understand in terms that some of us who are super nerdy like to talk too technical, and they don't really care about that. There are some deep dives in the book, but there are also just some general simple things in every chapter to get people to understand why they should care about these things.
There we go.
So that's the best place to get the book. You can go to prettygoodhouse.com or .org and also get to the link that'll go to the Taunton store to buy the book. So use the code. You can get that for a good deal. So since I'm calling this an event, it's a podcast. I'm throwing it out there.
And speaking of podcasts, you have a podcast too, by the way.
I do have a podcast. So this year in 2022, whatever year this is, 2022, I did it once a month. I used to do it once a week so you can catch up on old episodes. Essentially, I do the podcast because I like to talk to other super cool people in the industry. So it's really just me and having a good time. If anybody listens to it, that's awesome. But it's in support of architecture, building science, and female entrepreneurship. Woo-hoo. So I just want to be out there supporting women in the trades, really any minority getting into it, because guess what? The construction industry needs so many more people than they have. They need everybody to join. So like, get into it. It's something that you can be passionate about. Just forget about whatever stereotypes you think you might have heard. There are so many different avenues for people who are great at project management, want to work with their hands. There's rough carpenters, finish carpenters, electricians, plumbing. You want to get into putting solar panels on. We need like 5 times the electricians that we have licensed in the United States just to do solar movement. So like, get involved. It's cool. So that's what my podcast is about, usually.
It's like around the house. Usually, we get off track sometimes. It happens.
Everyone, I talked about garbage today, which I think is related, but like...
We've talked to music and hydroplane racing. So, we get off track sometimes. It's what we do here. Yeah. And then, of course, you're an architect. You do cool stuff with homes.
I am. Sometimes I do cool things with homes. Yes, I'm a licensed architect in Maine, Pennsylvania, and New Hampshire currently.
Nice.
And Utah. But I'm a licensed architect. I have a couple of people in my office. We do a lot of either high performance new construction. We have a semi-custom plan set, so you don't have to start from scratch. So we've got a bunch of those. I need to update my website to get everything consistent and on there, but just reach out. We'll tell you all about them. We also... we only really, for the most part, do renovations in Maine because you need somebody to be local if you have a renovation project.
There we
go. They need to have eyes on that thing a lot.
So all of our friends in Maine that listen to us on the radio in Millinocket at WSYY AM 1240, Emily's right around the corner.
I'm not too close to Millinocket, but...
You're not in Oregon. For me, that's right on the corner.
I'm not in Oregon, but you know what? Maine's a really big state, and some other places are closer than some places.
Exactly. I get it.
But yeah, that's awesome. I love it. We love what they're doing. Conservation all up in that area. So very cool stuff.
Very cool. So. Emily, thanks for coming on today. This has always been fun, and we're going to do this again because we just kind of scratched the surface again today like we always do.
I know, like, we meant to talk about some things, and then we just hijacked it and talked about whatever we felt like talking about today. So.
It's what we do.
Always a pleasure.
All right, thanks. I'm Eric G, and you've been listening to Around the House.
Somewhere unseen and undiscovered, anywhere beyond the mean. Life is a love song, let's be lovers. We're all over the radio. Take my hand, I know where to go. All over the radio with you.
Hey, it's Eric G from Around the House. Are you planning a decking or siding project this year? If you are, you've got to check out my friends at Millboard. Millboard is a completely different kind of composite decking and cladding that enhances outdoor spaces with enduring distinction. Hand-molded from the finest oak, it realistically mimics the natural grain and color of premium hardwood. If you're looking for something that doesn't look like plastic and instead real wood, check out millboard.com. Make sure and check out that interview we did just a few weeks back. That's millboard.com.